Hi, welcome to the second video in the Datadog 101 series. Datadog 101 shows you everything you need to know to get the most out of the Datadog platform. This video covers collection. How do you get the metrics and events from your host up to Datadog? Before I get into that, let me just explain what a host is as far as Datadog's concerned. A host is any computing resource that can run a job that you want to monitor and can also run the Datadog agent. That resource could be a physical box in a server room, a virtual machine or an instance on a cloud service, or even a Docker container. You can send metrics from a single host or thousands of hosts, and the number of metrics is only limited by the applications you choose to monitor. Throughout these videos, I'll be leveraging various resources, including the documentation, the application and its integration tiles, as well as the knowledge base. These are great places to go whenever you run into any issue with our platform and can help you solve most problems very quickly. The first step to collecting metrics and events is to install the agent. If you're setting up a trial account, the installation process will be right in front of you. For established accounts, visit Agent under Integrations and choose the platform you wish to install. Here you can see the installation process for Ubuntu. The command already includes your API key, so just copy and paste it into the terminal and run it to install the agent. The process for the other platforms is very similar and very easy for any single machine. But when you're working with thousands of instances, you'll probably already be working with tools like Chef or Puppet or Ansible, so refer to these sections for guidance. And if you need to install the agent on another operating system, such as Solaris or AIX, you'll want to review the Install from Source section. Now that the agent is ready, let's take a look at configuring it. Configuration happens in the datadog.conf file. The location of this file depends on your operating system, but you can find out more about that here. Within the configuration file, you can set up using a proxy, specify your API key and tags to use for this agent, configure how service discovery works, and all sorts of other things that are specific to your environment. One of the most important sections to edit is where you define your tags. You'll get so much more out of the product if you assign tags to each host and integration that you want to monitor. How do tags make things better? Well, let's say you have several instances of different sizes on a cloud provider. You could assign a size tag to each of them. Some get a tag of size small, some get size medium, and the rest get size large. These instances serve different roles, so you assign the tags role database, role web, and role cache. Finally, you assign tags based on availability zone, AZ US West, US East, or EU West. Once those tags are set up, you can more easily query the data and create dynamic dashboards that work with your environment. For instance, I can create a single dashboard showing the performance of all my hosts, and then by choosing a template variable, drill down to a smaller subset to see how my databases or my web servers are performing. We'll see how to leverage tags in more detail in an upcoming video, but it's crucial to implement a good tagging strategy. Take a look at this document for more about tagging in Datadog. When you make any changes to the configuration of the agent or any of the integrations, you have to restart the agent. The command you use differs on the various platforms, so refer to this URL for more on doing that. Now that you're collecting metrics from a single agent, let's take a look at what's being gathered. And I can do that from the metrics summary page. You can see there's some information about the CPU, disk, file system, I/O, memory, network, swap, and uptime. I'm showing an agent that's running on a Linux virtual machine. However, you might be wondering if anything's different if this were an instance on AWS or Azure or a VMware VM. We have integrations with those platforms, so is the agent even necessary? Well, for AWS, it's true that you could monitor all of your EC2 instances using purely CloudWatch metrics and not install any agent. However, even when you enable detailed monitoring for every EC2 instance, AWS only updates the metrics every minute. There's a lot that can happen in a minute. In fact, let's take a look at a chart in a Datadog dashboard that shows CPU utilization using the EC2 metric, and then overlay it with a metric coming from the agent. As you can see, a lot is missing from the story of this instance in the chart with only the CloudWatch metric. And it's a similar story with all cloud platforms. Looking at the system metrics is an interesting first step, but let's start to look at how to bring in metrics from other applications. That's where the integrations come in. We have well over 150 integrations at this point. Integrations make it easy to collect metrics on most of the applications used to power your environment. Integrations fit into four main categories. First, there are the hosted integrations that rely on an API key or secret or hook. These include services like AWS or GitHub. Then there are the local integrations that rely on an endpoint that we can reach to collect the metrics from the application. These could include MySQL or nginx. There are the notification integrations that might run locally or using a secret, but they primarily push information out instead of collecting information in to Datadog. These include PagerDuty, VictorOps, Slack, webhooks, and more. And finally, there are the frameworks, libraries, APIs, and tracing that you use to instrument your applications, as well as to build new integrations of every type. Let's take a look at setting up a few of each of these integration categories. One of the hosted integrations is AWS. Visit the Identity and Access Management console on your AWS account to create the role and policy. Then switch over to the Datadog tile to enter the details. Finally, enable the integration by clicking the Install Integration button. The goal here is to give Datadog enough access to the performance information of your environment without giving too much access to data that we don't need. You can read more about the actual steps here in the documentation. If you're using Azure, Google Cloud, or another cloud platform, the installation process is very similar, and you should refer to those sections in the documentation. Another commonly used hosted integration is GitHub. This requires getting the webhook from the integration tile and then entering it in the GitHub interface, along with setting how much detail to share. At this point, I'll move on to the local integrations and get a few of those set up. The first is nginx, which requires an nginx server with the stub status module enabled, which gives you an endpoint for nginx metrics. So I have an nginx server with that module enabled, and here's the section for specifying the metrics endpoint. Now edit the nginx.yaml file in your conf.d directory to include that endpoint. Specify your tags, restart the agent, and enable the integration in the tile. Whenever you add an integration or make any tweaks, run the info command to see that everything's okay. Another common integration with many of our customers is Docker. To get that running, just add the agent container by running the command listed and then enable the integration. If you want to add the nginx integration or another integration to that Docker container, load up a volume for your config files. In this command, you can see I'm adding a volume for the configuration files. This includes the nginx YAML file, since I have nginx running in one of my containers. Let's add one more local integration, Postgres. Setting up the Postgres integration requires configuring a local Postgres user and entering that information in the integration configuration file. Enable the integration and restart the agent. Over time, we update our integrations to work with the latest versions of applications. To ensure that you have the latest, run the agent install script again. Then you can review the conf.d directory to find the most recent example configuration files for each integration. You can also see these files in the dd agent repo on GitHub and navigate to the conf.d directory. When working with any integration, especially when you're not an expert in the technology, it can be very helpful to look for related posts on our blog. For instance, here are some of the results of a search for Docker on the blog. Pick a technology we support, and we probably have some guidance on how to monitor it. And if you're new to monitoring in general, be sure to look out for our Monitoring 101 series of posts. These can be super useful for getting a complete view of what to look for when monitoring. The third type of integration is the notification integration. These are how we extend the methods of notification used by Datadog. I'll go into a lot more detail about the notification integrations in a later video. The final integration type is a library or framework. We have libraries available for C#, Go, Python, and Ruby, and our customers have written additional libraries for Elixir, Java, Node.js, PHP, Scala, and more. Take a look at this section of the documentation to see the different libraries available. Now, one thing you may notice here is that some say they're API wrappers, while others refer to themselves as dogstatsd clients. So let's go a bit deeper and get a better understanding of what components make up the Datadog agent. The agent is made up of 4 major components. There's the collector, the forwarder, dogstatsd, and supervisord. The collector does much of the work of collecting metrics every 15 seconds or so. It runs any additional tools required and connects to the various monitoring interfaces employed by your applications. Dogstatsd supports statsd, a metric aggregation daemon created by Etsy. The big difference between dogstatsd and statsd is that we add tags and some other features used on the Datadog platform. Dogstatsd is employed by a couple of integrations and by any of the libraries mentioned that are dogstatsd clients. Both dogstatsd and the collector then send the metrics collected to the forwarder, which forwards them to Datadog over HTTPS. The forwarder will store metrics collected if the network has a disruption of any kind. When the network comes back, the forwarder sends the metrics along. The fourth and final component is supervisord, which runs the master process and forks all subprocesses as the user DD agent. To learn more about the details of the agent's architecture, you should take a look at this document on the GitHub repo for the agent. Now that you know about the different components of the agent and the various libraries available, you might be wondering, why would you want to use dogstatsd versus using the API directly? The biggest benefit of using dogstatsd is that your network traffic will be significantly lower. Note that when submitting metrics via dogstatsd, we're going to generate a histogram and submit that on each flush of the forwarder, which is about every 20 seconds. And that is pretty much everything you need to know about getting metrics into Datadog. I hope you found this video useful, and if there's anything you wish we covered but left out, let us know. In the next video, we're going to talk about the different ways to look at the metrics that you've been collecting. Thanks so much for watching. Goodbye.